This video will look at translators and facilities of languages. Now, as we know, CPUs, they're very impressive, but they can only process ones and zeros. So actually, when it comes down to it, they're quite simple machines. They don't understand how to process programming code in the form that we as human beings write it. So, Python, for example, high-level languages, the code that we write, CPUs don't actually understand how to process them in the form that they are written. So what has to happen to get our code into a form that the CPU can work with? Well, ultimately, it needs to be converted into machine language. So we have an idea, we write an algorithm, the logical steps for that software solution. We then might code the solution in a programming language, but then before the CPU can process it, it has to be converted into machine language. So what is machine language? Well, machine language is a very low-level language. It is made up of code instructions and data and represented in binary. So each piece of machine code is stored as a binary number. It's then decoded and executed by the CPU's logic circuits. So because it's represented in binary, it's very difficult for human beings to write code in write programs in machine language. Very difficult indeed. So to overcome it, assembly language was created. So this is a language which is fairly low level in itself, has small sets of commands which represent certain pieces of machine code. So it helped programmers because they didn't have to remember these sets of binary numbers. Instead, they learnt the commands. So instead of remembering what a combination of zeros and ones actually meant, they could just remember commands like add for adding or sub for subtracting. And these commands are known as mnemonics. They are simple memory aids, just ways to represent sets of binary code. Now, it's still quite difficult to learn and use, which is why high-level languages were produced, but it does still have its place. If we want to make a CPU work very, very efficiently, for example, in an embedded system, perhaps we're creating a device that only has to do a certain number of tasks, then writing an assembly language can make that CPU work very, very efficiently indeed. Ultimately, there's less code for it to process. So, high-level languages. We've obviously looked at machine code, we've looked at how assembly language helped programmers program in the early days, but there were still some issues with assembly language. It's still pretty difficult to code in assembly language, and that's when computer scientists started developing why they started to develop high-level languages, such as Python and Java. So high-level code, also known as source code, much easier for humans to write and therefore humans to understand. And its purpose is to be easier to write and still be easily translated into machine code. Because obviously anything that the CPU processes has to be in zeros and ones. These languages have to still be translated, and the way that or what helps in the translation process is that all programming languages make use of keywords, key syntax, certain rules for the language, and this allows for the programs that we write to still be translated because they're all written in a consistent format. So using keywords as opposed to any old English means that translations can happen. So how do these translations happen? Well, by using something called a translator. So every programming language will come with a translator which will translate the program code that we write into machine code. So translators, they are bits of software that convert high-level language commands, for example, print, if, and for, and while, into machine code commands, so set pieces of binary numbers that the CPU can then process. And they work in two ways. You can have translators that take the whole code, they convert it into machine code in one go, so that you can then later run the program, and that's known as compiling. It packages up all of your program code into one file that can then be run on a computer. The second way that translators can work is they can take the code one instruction at a time, they can translate it, and they can run the instruction before translating the next instruction. And this is known as interpreting. And for this sort of translation to happen, there needs to be an interpreter alongside the program code at all times. So again, a compiler converts the whole code into one file, an executable file. The file can be run on any computer without the translator needing to be present. It can take a long time to compile the source code. The translator will have to code all or convert the instructions into various sets of machine code, as different CPUs will understand instructions with different machine code from one another. But once that program has been converted, it will run very quickly. Now, one of the downsides of a compiler is that if there is an error in the code, it won't be able to compile, and it will be very difficult to find out exactly where that error is. Now, an interpreter, as we just heard before, converts the source code into machine code one line at a time. So the program does run very, very slowly. Okay, you need the interpreter alongside the program when that happens. But a really good benefit from using an interpreter is that you can identify where the errors are, because it does it one line at a time. As soon as one line of code can't be converted because it's perhaps has a syntax error, then the interpreter will not be able to convert and run that line, therefore highlighting exactly where that error is. The translator has to be present on the computer for the program to be run with an interpreter, which potentially is a downside. Now, there are two types of translator that allow you to convert high-level language into machine code. Now, there is one other type of translator that you should be aware of, and that is a translator that converts assembly language into machine code, and that's known as an assembler. So this type of translator is used for assembly language, not high-level languages. It converts mnemonic assembly language instructions into machine code. Now, when writing programs, we could write our programs in machine code, as we've already talked about, but that's exceptionally difficult. We tend to write them in high-level languages, and to help us with that process, there are software known as IDEs, Integrated Development Environments. Now, this software package provides the tools for programmers to develop software. It allows us to write our high-level code, test it, and translate it. So let's have a look at some features of an IDE. So you'll have IDEs that will be specific to certain high-level languages. You may have some that are multi-purpose that can be used to write different programming languages, but they will normally consist of an area where you can actually write your code, so a source code editor, an interpreter, so a translator that allows you to translate one line at a time, one line of the code at a time for testing purposes. Automation tools, so automate tasks by finishing off the keywords and indenting on your behalf. A debugger, which identifies errors and shows you where they are. A compiler, so another type of translator that will allow you to package up your program into an individual program file so that it can be distributed to other users. Auto documentation, so this stores lists of variables, modules, functions which are documented for other programmers.